What's up, guys? I hope you all are doing well. Welcome back to my YouTube channel and welcome back to another YouTube video. In this video, we are looking at part 9 of our Pandas tutorial series in Python. So, to kickstart this session off, what we will talk about is a very interesting and easy topic that is known as sorting and ranking our data. Okay, so you guys know sometimes we need the data in a table ordered by a certain column or just represented or shown to us in a certain way. And this is what we are going to kind of learn in this video. Okay, so let us proceed to do the most important thing. So go ahead, guys, import pandas as PD and work with me. So we will create a simple series object. I'll call mine obj. You can call yours anything else you like. So we'll set the data of this series object to be a range of 4, which means 4 values. Therefore, when passing our indices, we shall pass 4. Let's pass D, A, B, and C. So if I print obj to the screen, you guys know this is what we obtain. So now I'd like to show you something of how you can sort the indices of the values themselves. So what I'd like you to do is create a new obj, a new object, and we are setting that equals to obj.sortIndex. Now sortIndex is a method that you call on your data frame or series object. In this case, it's our series object. And just to show you the parameters themselves, it is set to a default axis of 0. Now that tells us now that we are sorting these values according to row. Okay, I told you guys in a previous video, always remember this, that when they say an axis is equals to 0, it's the same as saying row-wise operations. Okay, and axis is equals to 1 is the same as saying column wise operations. Now I actually ran the script by accident again, but anyway, what got printed out is obj again, right? The original object. So now what I want you guys to do is print new obj to the screen, and you guys are going to see what we obtain. And what we obtain is as a result of the sort index method. And this is what we get. The initial indices or the indexer column was D, A, B, C. And by calling the sort index method, we effectively obtain A, B, C, D. The values themselves are still assigned to the respective index values. Okay, so all that has happened is there has been a reordering of the rows of the series object, and that's what the sort index method does. So it does this automatically, like logically speaking, A, B, C, D is an order. Okay, now that is fine. Now I'd like to demonstrate for you how we sort but on a data frame object. So we'll do this once again. Import pandas as pd. We'll set up data frame is equals to pd dot data frame. Go ahead, guys, import numpy as well, and within the data frame we shall pass numpy dot a range of 8. So we'll reshape this array to have the representation of 2 by 4, 2 rows, 4 columns. What I shall do next is I shall pass the index itself, and I shall give the indices the names 3 and 1. So that is fine. Next, what I'd like to do is columns is equals to D, A, B, C. Now the interesting thing about a data frame, right? The only most important way in which it differs from a series object is, you guys know, it's a 2D kind of structure. There's rows, there's columns. With respect or with regards to the series object, yes, there are rows, yes, there are columns, but there's only one column, and that's not really, it doesn't give us, I would say, the access or the ability to do various kinds of sortings and indexing on that object, whereas the data frame will have the ability to sort and restructure whatever according to rows and columns. So it's kind of complex and it gives us more versatility, right, into the levels of ordering that we'd like to impose on the data frame's data or values. So I will run this now and you guys are going to see this is the data frame we are working with. This data frame is a 2 by 4 telling us that we have 2 rows and 4 columns. Now, that's fine. What I'd like to do now is I'm calling the sort index method on the data frame object. So data frame dot sort index. This data frame is going to get sorted according to rows. So let me go ahead and run this, and you guys are going to see that instead of 3 and then 1, it shows up as 1 and then 3. Now that is fine. I should mention to you that data by default is sorted in ascending order. The data is sorted in ascending order by default. Okay, that's how the sort index method actually works. So you guys may be wondering, right, what if I need to sort this data frame by the column? Okay, so let me show you how that will be done. I will leave this here and I will comment that out. I will create a new print statement for us. So sort index, and within the sort index function or method, what you want to do is change the axis parameter from equals to 0 and set it equals to 1. And now when we run this, remember the original data frame looks like this. So let me just pull that up for us. This is the original data frame. 3, 1, D, A, B, C. We are sorting now by columns. So let me run this and you guys see that 3 and 1, the rows are still the same, but the columns have changed their order, right? From D, A, B, C, it now shows up as A, B, C, D. So that is interesting stuff. Now I'd like to show you how you can also sort the values or the data in ascending order. Now ascending order is defaulted, so I want to show you how you can do it in descending order, sorting the values, or let's say sorting the data in descending order. Okay, so this is what we have: print data frame dot sort index, and we'll sort according to the columns as well, and I want it in descending order. So to do that, I'll do ascending is equals to false. I don't know if you guys saw that, but ascending is basically a boolean value, okay, and basically it is defaulted to a value of true. Okay, so to do ascending is equals to false, it means that it is descending order. So ascending is equals to false. And now you guys see DCBA. That's what we obtain. So that's fine. Now I would like to show you one more interesting concept. So this is how we sort a series, sorting a series by the values inside it. So sorting the series by the values inside it, not by the header row or by the indexer column. Now we are looking at the values inside the array itself. So what I'd like you to do is import pandas as pd. We're going to set obj to be equals to pd dot series, and within this let's pass 4, 7, -3 and 2. Now print obj. You guys are going to see Python automatically gave it the numerical indices 0 to 3. The values themselves are 4, 7, -3 and 2. Now we want to sort this little series by the values. So let me show you how that's done. I'll comment it here. We use the sort values method to sort the data according to the values themselves. So let me show you guys. Print obj dot sort values, and just call it as is for now. Do not worry about the parameters. You guys can see the parameters are similar to the sort index parameters. So when I run this, you guys see the indices themselves, the indexer column has been restructured to accommodate the sorting of the values themselves. It is sorted by default in ascending order. So ascending order is lowest to highest, as you see, -3, 2, 4, 7, as opposed to what we had, 4, 7, -3, and 2. So that's that. Now, I would like to show you what happens when you have missing values in the series and you attempt to sort it in ascending order. So let me show you this. I will just comment that out. I'll do obj is equals to, or let's do object2 pd.series. Within this, I will pass 4 numpy.nan. I will pass 7. So 4, it's a nan, we have 7, another numpy.nan, and let's do -3, last but not least, 2. Print obj. What you guys see is we have, okay, so I should make this obj2. There are 6 values here, 2 of which are null, so nans. Now, what I want to show you guys is, so this is the default series that we have at the moment, right? Now, when I call the sort values method on this object, I want you guys to pay attention as to what happens to the nan values. Okay, now I control enter and you guys will see this is the answer to your question. By default, the nan values get sorted to the end of the series object. Okay, that's what happens. Now, you guys are wondering, this is ascending order, right? What happens if we specify ascending is equals to false? What happens to the nan values then? So ascending is equals to false. As you guys see, it does not matter whether it is ascending or descending order. NaN values by default will always get placed at the end of the series object that you are working with, okay, with respect or with regards to the sorting operation. Now, that's all fun. This is all on series. So what about data frames now, right? Let's go ahead, import pandas as PD. And now I will try to demonstrate for you guys the concept of sorting on a data frame. Now we are sorting by values. Remember guys, there's a huge difference between sorting by index and sorting by value. Values are the data themselves, the data inside the object you are working with. The index is referring to the indexer column and the header rows. Okay, so that's basically the main difference. Now, data frame is equals to pd.dataframe. Within this, we'll just construct a dictionary. I'll have b and I'll set these values to be, so let me space this out for you guys, and I'll set this to be 4, 7, -3, and 2. So that's the first kind of data row that we have. What I'd like to give us is another column. I'd give us C, and here another array 0, 1, 0, 1. So that's that. Print data frame. It's an easy or simple data frame that we are working with. The main goal is for you to see what happens and how it works, you know, when we actually sort values. Now, the cool thing about the data frame, because of the fact that it contains more than one column, we need to specify the column that we want to sort the values by. Okay, and don't stress, I will show you, because logically speaking, you can sort by one column or you can sort by multiple columns. So this is just a test run. I want you guys to just do print data frame dot sort values, and the keyword that you see here, the parameter, is by. We need to specify by is equals to, and in a string form the name of the column. This is when you are sorting by one column. Okay, so data frame name dot sort values by is equals to and the name of the column. Suppose we'd like to sort this little data frame by the column maybe B. So let's do B. By is equals to B, and when I run this, you guys are going to see that the column C gets ordered according to column B, because column B is getting priority. It is now going to be sorted in ascending order, and as you see, -3, 2, 4, 7, ascending order is lowest to highest. Now let me show you how you can sort by multiple columns. So I'll just uncomment that. Now by is equals to, for this sorting by multiple columns, you need to pass all the columns that you want to sort by as a list, okay, a list of the column names. Now the order in which you pass the columns within the list is basically the order in which the columns will be sorted. It will basically be given priority. So first we want to sort by B, and then we want to sort by C. Now I do control enter, and you guys can see. Now there's no change observed in our data frame because of the fact that we are working with a small data frame and there's not much, variance in the data that we are working with. But when you run this code on a larger data frame, you will notice changes in the data itself, okay, the order of the data. Now that's fine. In case you are wondering, now you see the process or that technique of sorting multiple columns, of sorting data by multiple columns, it's basically known as ranking, right? This little portion here, by is equals to, and the list of columns that you pass, that is called ranking the data. Okay, we rank it according to what's more important for us to sort on. So I hope that makes sense to you guys. Now, let me show you how we can manually rank the data. So create a new cell, ranking the data. Now you may ask, what is this concept of ranking? Now let me just give it to you in a simple statement. Ranking the data assigns ranks from 1 through the number of valid data points in the object. Ranking the data assigns ranks from 1 through the number of valid data points in the object. So if you guys don't know exactly what this means, don't stress, I am going to demonstrate this to you now. So import pandas as PD, and now we are going to set obj is equals to pd.series. Within this I shall say 7 -5. Let's do 7 again. Let's do 4, 2, 0 and 4. Now print obj to the screen. Have a look at how it looks, guys, and this is what you will see. Now this is a cool method, introducing the rank method. I want you guys to do print obj.rank and call it as it is. Okay, it is defaulted to axis is equals to 0, which tells us everything is being sorted or ranked according to rows. Okay, now I do control enter, and this is what we obtain. We obtain a little series that has the ranks of the data itself. Now that is fine. What I'd like to show you guys next, right, is how we have the ability to assign ranks according to the order in which data is observed. Okay, so let me show you guys this. I will comment this out for now. What I'd like to do is print obj.rank, and within the rank method or function, you want to use the parameter name method is equals to first. And this, in essence, what it's going to do, it will rank the data or the data points in the order in which it is observed. So control enter, and this is what we see. Okay, each of these values depicts the ranks of the data points themselves. Now, that's fine. What I'd like to show you next is, so we don't have very much more to do for this video. I am saving a few of the concepts to discuss in the next video. For now, what I'd like to show you is something easy, something to just lighten up the ending of this video. It is known as access indices or indexes with duplicate labels. You guys know we've spoken about this at the, I think at the beginning, around the beginning of this tutorial series, we spoke about this object, the index object, and we learned that it does support duplicate values in it. So now I just want to show you guys how you can have series and data frames that have duplicate indice values. Okay, so go ahead, import pandas as pd, and I want you guys to do obj is equals to pd dot series. Within this, we'll do range of 5, and index is equals to a. Let's do b, or let's do 2 a's. I want 2 b's and 1 c. So a b b c. Now print obj. You guys are going to see we have a series, but you know, there are certain values in the indexer column that are basically duplicated. There are 2 a's, there are 2 b's. Now let me show you this cool feature. So suppose you have a very large series object that you are working with, and you'd like to check if all the values in the indexer column are unique. Okay, so the way in which you can do that is basically by using this method. Use the index, it is called is unique. So let me enclose this in parentheses or quotations to check whether the values in an indexer column are unique. So obj, now that's the series object itself. We need to call obj.index, that's the index for the series, and on the index we call .is unique, as you guys see. Now when I run this, we should get a boolean which says false. So control enter, and you guys see we do obtain a false value. Now that's fine. You guys know, I mean, apart from all of these ranking, sorting, and indexing and so on, the basic and bare minimum that can be performed with our series objects is that of indexing and slicing. Now, the question is, what happens if we try to index a series that has duplicate indices in the indexer column? So suppose I want to return the value that is at index A, but now we have 2 A's. So how does this work? Will we be shown the first one, the second one? Will we be shown all values that have the index A? So I will hit control enter, and you guys see that is exactly it. We get shown all the values that match that specific index that we are trying to retrieve from the series object. Now if we do print obj, let's do c. There's only one c, so we'll only get one value. Now that is fine. I would like to show you a similar concept, but with regards to a data frame object. So import pandas as pd. Let's do df is equals to, import numpy as well, guys. We will use numpy to generate our data. So pd dot data frame, within this numpy dot random dot randn, and we shall say 4 by 3. Now index is equals to, and let's do a list object a and B, B. So AABB, that's the indices or the indexer column. So print DF, this is what we see. Now, let me show you what happens when you try to index a data frame that has duplicate values or indices in the indexer column. So let's do a simple print df dot lock, and we shall say B. We want index B. So when I do control enter, it follows the same rules as the series object. We get shown all of the values from the indexer column that meets the criteria we are looking for. So that's fine. And with this, guys, we shall end the video here. In the next video onwards, we shall explore more features. For the next video, we're going to kickstart things with basically computing, or basically, just to summarize it, descriptive statistics. That's what we will look at in the next video. So thanks so much for watching, guys. Thanks for staying till the end of the video. Good luck with your work, and I will see you in the next YouTube video.